Hey, Chem Rockstars. Today we have our last little bit of notes, but we're going to take it on two separate videos just because that way you have time to practice each before you do the other one. But you can watch both videos back to back. I just also didn't want to get them too long, okay? So without any further ado, we're going to start with the processing 2.4. This is writing electron configurations, no shorthand, even though we're learning the shorthand today. So go ahead and answer this question, hit pause, and then meet me down on the 2.5. You will need your periodic table handy. That's why I have inserted mine right there. So let's get going. 2.5. This first video is just going to be about the shorthand electron configuration. We're going to still put it on the same page. We're just going to try to make sure that the video doesn't present too much information all at once. So let's jump right in and talk about our noble gases. So noble gases are kind of what all elements are trying to strive for because they have a full valence shell. All right, full valence shell. They are also group 18, which is all the way to the right. So as you read, it would be like right before you start over. So let's look at that on our periodic table. Notice how my noble gases are marked. Yes, there's probably a little bit more coloring on my periodic table because this is one that's kind of the finished product and we're just going to keep rolling. But remember, you may mark this right there, noble gases, on your little sheet. Okay? On your periodic table. So let's take a little gander here. We've got electron configurations for the following elements. So we've got neon, which is Ne. All right, it's got 10 electrons. And just kind of reviewing what we did the last time we had a video, we've got 1s2, 2s2, and 2p6. That's the electron configuration for neon. Now, if we do that for sodium, sodium is Na, and it has 11 electrons. So just one more than neon. So we would say 1s2, 2s2, 2p6, 3s1. Awesome. Now if we do aluminum, it's Al, and it has 13 electrons. So a couple more than neon. So 1s2, 2s2, 2p6, 3s2, and then 3p1. Now if we look at all three of these electron configurations, we can see that they all have in common, and in fact anything past neon would have this 1s2, 2s2, 2p6 in it, right? So why not save ourselves a little work and kind of use that as an abbreviation? And that's what we do. So the first step that we do is we find the noble gas that is prior to our element. All right? And so that means in the prior row. Okay? Then we put that noble gas symbol in brackets. So in this case, it would be neon, right? And then we start with whatever row we're in. So if we were doing sodium, that would be the 3s, but that's going to change for each element. So I'm going to leave that blank for right now, but what we're talking about is we're going to do that for each one. So let's take a little peek here and let's do sulfur, and we're going to kind of scroll back up in just a second. So we find sulfur. It's S. I'm trying to write with an eraser. That's not ideal. We've got sulfur. It's got 16 electrons. So let's go to our periodic table. All right, here's sulfur. All right, the noble gas prior to it in the row before it is neon. So our first step is to put neon in brackets. So we'll put neon in brackets there. Everybody with me on that? Awesome. Okay, we've got that. Now we're going to start with that next row, which means right here, which is row 3, and we're going to say 3s2 because each of these, 3s1, 3s2, that counts, right? So that gets us through magnesium, 3s2. Sorry, we're going to do this one more time. And then just keep reading left to right. These are P's, right? Mine are outlined in orange. My P's are, there they are, in orange. So we count P1, P2, P3, P4. So S would be 3P4, and that is our shorthand. And the other thing about our shorthand is we now don't have to memorize that long little 1S, 2S, that little ditty. Okay? Awesome. So let's check out xenon. Xenon is Xe, all right? And it has 54 electrons. So let's look up to our periodic table. All right, we're going to change colors too, just to make sure. Here's xenon, right here. All right, Xe. And we go to the noble gas prior to it, so the one just above it is krypton. So in brackets, we're going to put krypton, Kr. All right, in brackets, we've got Kr. Now we start with whatever row, that next row, which is what the row xenon is in. Xenon is in row 5, so we're going to say 5s1, 5s2. All right, 5s2. That takes us through strontium. Okay, now we got to keep rolling. These are Ds, so we say, remember, our Ds are one less than the row we're in, so we got 4D, and that would be 10 if we count across there, 4D10. So write that number down. Okay, keep rolling. Now we're in our P's again, so P1, P2, P3, P4, P5, P6. So we're going to say 5P6. Now, if we check, we can count ourselves. We've got krypton. All right, this is us checking. Krypton has 36 electrons. Add those 2, which is 38. Add those 10, 48. And then add 6, which gives us 54. We've done it right. Awesome. Let's change colors one last time. Let's go green, right? All right, we've got iron, which is Fe. Okay. It has 26 electrons. Woo, 26 electrons. So our first step is to find iron. Here it is. Here's iron. Right in the middle. Okay. We find the noble gas prior to it. In the row prior to it, that would be argon right over here. All right. So that's what we're going to start with. Ar in brackets. Okay. We've got Ar in brackets. Now, again, we start with whatever row iron is in. Iron is in row 4, right? Iron is in row 4. Here's row 4. So we're going to say 4s2. Then 3d. 1, 2, 3, 4, 5, 6. 3d6. So 4s2. 3d6. That's where this video is going to start. We'll hit the next one in just a couple of seconds. See ya. Bye.